Let's start a new chapter today. We're talking about ratios. Now, ratios, or anytime you see the word ratio, we're talking about a fraction. And sometimes you can even see it in other words. And that means we're talking about fractions. For example, when we talk about things that are rational in mathematics, notice that in the word rational, you see the word ratio. That means we're talking about fractions there. Now, when we talk about these fractions, we're talking about them in a reduced form, and you use ratios all the time. For example, if we were to talk about the ratio, okay, we're going to write this down, all right? The ratio of, it'd be really funny to say the ratio of boys to men, but the ratio of women to men in this classroom right now. Okay? Let's see, we have 6, 7, 8, 9, 10, 11. We have, what is the ratio of women to men in this classroom? You guys looking around, trying to figure out who's a guy, who's a girl? Let me just clear this up for you. There are 12 women to 4 men, right?
Counting yourself?
I'm not including myself in this. We're talking about students. So the ratio of 12 to 4, we'll say the word 2, and that means 12 to 4. We could also say this, 12:4. That's how we would do the ratio. And it's the first part is the first part that's mentioned, women, and the second part is the second part mentioned, men. Women to men is 12 to 4, 12 to 4. I could even write it like this, 12 to 4 as a fraction. Oh my word, not a fraction. Yeah, a fraction. But do I like 12 to 4? No. I might reduce this better and say what? You said it, Lisa. You mouthed it, or are you just calling me names? How do you reduce it? Yes, to what? Right, we know that 12 over 4 is the same as the fraction 3 over 1, right? Now, if this were just any other normal number, 12 to 4 would just, or 12 over 4 would equal what? What's 12 divided by 4? It's just 3, and we would write just 3, right? But when we're talking about rates or ratios, and rates are very much like ratios except they carry units with them, ratios have to be something to something else, so it has to be a fraction. So you could say that the ratio 2 to 4 reduces to the ratio 3 to 1. So suppose this were like a huge dating scene, all right? The guy's going to be going, hey, I just did the math. Okay, number one, you're not going to get with any girls. That's beside the point. But I just did the math, and guess what? There are 3 girls for every one of us. May the odds be ever in your favor. Do y'all agree? Maybe you don't agree. The odds are never in our favor. What if I have a rectangle? Mr. Craig, but you are square. Hey, back up there. You're being kind of rude today. If this is 20 feet and this is 42 feet, okay? I want you here to find the ratio. Find the ratio of the height to the length. By the way, it's height, not height. There is no height. LOL, right, Karen? So, what is the ratio of the height to the length? Now, the first part that's mentioned is the height, so that's what comes first. So if you want to do this as a fraction, that's going to be your numerator. That's the first part that we say when we're talking about a fraction anyway, right? Is the numerator? Necesita. Est-ce qu'il y a des questions? So we would write what as a fraction? Isn't the height 20? So that would be 20 feet to what? To 42 feet. Now notice that we have feet to feet, right? So as long as the units are the same, we can easily reduce this and make a nice ratio. And here's one of the neat things. You can reduce these feet as though they were common factors. So 20 feet to 42 feet would then reduce to the fraction, what? How do you reduce this guy? By the common factor of 2, right? So reduce these by 2, what do you get? You get 10 to 21. Do y'all believe that? That means that in this diagram up here, for every 10 feet, there would be 21 feet, right? If you were to reduce this, or you're talking about scaling this, okay? So since I have 10 feet here twice, I would have 21 feet here twice, okay? Now you guys see ratios all the time, I bet, and you don't even realize it. Does anybody here watch movies? Okay, I watch movies. Anybody else? Just a couple of people? All right. Do you guys, you probably don't remember this, but there was a time whenever we didn't have quite the proliferation of widescreen TVs and high-definition monitors. Do you remember that? You may even have TVs like this, right? I know I still have one. TV that I bought, almost 14 years ago. Okay? Now, when you're looking at buying DVDs, did you guys ever pay attention to the aspect ratio, or would you only buy widescreen or full screen, or do you remember that? Huh? You buy full screen? Now, here's some fun information for you. If you're talking about a TV set that was just a normal TV set, okay, maybe it looks something like this, okay? There was a ratio that was defined for these normal TV sets, okay? And the ratio was 4 to 3. It's a 4 to 3 ratio. And what this means is that for every 4 units of width, you had 3 units of your height. Okay? That was the way the ratio worked. Okay? So if, for example, and this is where we're going to be seeing things later on, how or what would the dimensions be for your old classic boxed set that would have been 20 inches wide? What would the height of the screen have been? What do you think? If I'm saying that it's a 4 to 3 ratio, right? 4 is for the width, 3 is for the height. So if I'm saying that the width is 20 inches, what would be an equivalent fraction to this? What would you say, Dennis?
15.
15. So it means the height of this would be 15 inches. Right? And you notice that the larger that the TV screens get, the ratio is still going to be the same. It still reduces back down to 4 to 3. That's what a full screen would look like. However, when it gets to widescreen, that's a completely different story.